Welcome. This is another video out of Khan Academy. We're in Algebra 1 and the unit is Quadratics Multiplying and Factoring. This skill is called Perfect Squares Intro. So we're going to factor as the product of two binomials this quadratic expression. And so I have listed over here the steps that you should think through when you're going to do any factoring of a quadratic. I mentioned in the previous video that you can always use the quadratic formula, but at this point in the series we haven't learned the quadratic formula yet. So we start with steps 1 through 3, whichever ones of those we need. So we look first for a greatest common factor. In this set of problems there's not going to be a greatest common factor because it's the intro level, so they're giving us something out of just section 2 that's straightforward and has no extra steps. So there's no common factor of those terms. There's x's in these two terms but not in the third one. There's a coefficient of 1 here which can't be reduced, so that there's no common factor that's greater than 1 between 1, 8, and 16. So we have no greatest common factor. So we look, do we have a difference of squares or a perfect square trinomial, because those are special cases that have patterns that make it easy, relatively easy to factor. And of course the title gives it away, right? This is a perfect square trinomial. It's a trinomial because there's 3 terms. It's called a perfect square. One way to think about it is because when we factor this, the two factors are the side lengths of a square, not just a rectangle, but a square. So that could look like this. So I'm going to have a square where I've got congruent sides, which means the side lengths are the same. So whatever the factor is here, it's going to be identical to the factor here that gives me an area, length times width, of x squared minus 8x plus 16. Okay, so there's a pattern that we know of, or that we can know about, that makes doing this simple. But before we know it, if we want to figure out what that pattern is, we would, with this case, we can see what happens. So we're going to have something times something, and they have to be the same because they're the side lengths of a square. Something times itself needs to give us x squared. Well, that would be x times x. So we do x times x. And then we're going to have a number here and here, same number because it's square, these are identical terms. That number times itself has to give us 16. Okay, you might be saying, well, 4 times 4 is 16. That's true. Now, the last thing that we need is a sign. We either are going to have x minus 4 or we're going to have x plus 4. Okay, they have to be the same because this is a square, so the side lengths have to be the same. Look at the middle term. The middle term is negative 8x. You get that middle term by multiplying the first term by the last term, and then adding that to the last term times the first term. Okay, so if I'm going to get a negative number by adding two things, then both of those things better be negative, right? Okay, so if I multiply this out, I get x times x is x squared. X times negative 4 is negative 4x. Negative 4 times x is negative 4x. And negative 4 times negative 4 is positive 16. Now I have negative 4x minus 4x. That's negative 8x. So x squared minus 8x plus 16 is what we get. All right, so that's the work you can go through if you don't know the pattern, right? But there is a pattern. If you have a perfect square where these two factors are identical to each other, it's going to hold this same pattern. So let's generalize it. let's generalize this. We notice that the term here, the first term, is the square root of the first term. So we get, we're going to take the square root of our first term, and then the sign is going to be the same sign as whatever our middle term is. So this is either going to be plus or minus, which comes right out of whatever that sign is. That's the one you pick. In this case, we picked a negative because we saw we had a negative. Okay? And then the last term was the square root of whatever our final term was in the original expression. So that was the square root of 16 in this case. What if we generalize that? What if we say that our perfect square trinomial is a squared minus some number, we don't know how many, times that first term, plus, and we'll put a plus here because we're generalizing, and then we have a square term here. Okay, if that's the case, if it's a perfect square trinomial, k is going to be something specific. Let's figure out what. Okay, so this becomes a, remember, a plus b. We're taking the first term square rooted, and we're going to do plus the second term square rooted, and then we square that, right? This times itself, that'd be this factor times itself, that's why it's square. Let's expand that and figure out what does k have to be. Okay, so this is a squared, that's a times a, plus a times b, plus another a times b, plus b squared. That was a plus b times a plus b, like that. Now, there's two of them. There's always two of them. That's how this expands when we use the distributive property. So we can say that's a squared plus 2ab plus b squared. Okay, so if you look at this, we know now that k is always going to be 2. And there's going to be a b in there. Okay, so to be careful, see how we thought through that and solved what the middle term it needed to be, because I didn't have it off the top of my head, and that's okay. That's how math works. We think through and substitute. That's one of our powerful methods for solving things. So now we know that if we have a trinomial that looks like this, a squared plus 2 times the first term times the second term's square roots, plus this b squared, another squared term, then it factors into the square root of the first term plus the square root of the second term, and like we said earlier, that plus is going to be determined by the sign of our middle term. It's going to have to be negative if the middle term turns negative. Okay, so in this case, we want x minus 4 times x minus 4, which we can write like so. X minus 4, and we can square that because it's x minus 4 times itself. Good. All right, so here we have a square. It's got 1 plus 2x plus x squared, and we just discovered that the factors of a perfect square trinomial are going to be the square root of the first term, 1, the sine of the middle term, plus the square root of the second term, x. Square root of x squared is x. So the side length, now be careful in these problems. Be careful in these problems. The square below has this area. What expression represents the length of one side of the square? This time they didn't ask us for both factors of the trinomial. They asked us for the length of one side. That's 1 plus x. That's all it is. We don't square that to give the side length. So I actually am going to not write it with parentheses because we don't need them. So 1 plus x is one of the side lengths. And we're good. Next one. Factors the product of two binomials. So this time they want both factors. The first term square, the second term square. The middle term is 2 times the square root of the first term times the square root of the second term. Right? So we have 2 times the square root of 36 times the square root of x squared. Well, 2 times the square root of 36, square root of 36 is 6. Square root of x squared is x. And so the middle term is 12x. Or the 2 times the square root of the first term times the square root of the second term ends up being the middle term, which is how we know for sure this is a perfect square trinomial. It's not just because they gave us the title that gives it away. They won't always give you the title. There will be quizzes, there will be unit tests and there will just be problems in life that have perfect square trinomials that you'll need to recognize. So that's how you figure out that it's a perfect square trinomial. First and last terms are square, and the middle term is 2 times the square root of each of the first and last term. Okay, fair enough. It's a perfect square trinomial, and we know that both of the factors will be the square root of the first term, 6, the sign of the middle term, which is positive in this case, the square root of the second term. So that's one of our factors. It's both of the factors, so I need to square that, and that's my answer. All right, this is a square. What expression represents the length of one side, so only one of the factors? It's a perfect square trinomial because the first and last terms are squared, and the middle term is 2 times the square root of the first term times the square root of the second term. This is 2, so 2 times 2 is 4. The square root of x squared is x. That's our middle term, so we know it's a perfect square trinomial, besides that they told us this is a square. All right, so one side length is going to be the square root of the first term, x, sine of the middle term, plus square root of the second term, or the final term, the constant, 2. And we're done.